15% unemployment at the outbreak of the Second World War. Look what the Second World War did to unemployment in the US. I mean, there's nothing like a war and all that war production to kill off unemployment. And I mean, guess what happened in the 80s? Does anyone know what happened in the States in the 80s? What Reagan did? Massive remilitarization, like massive military spending. Who knows what will happen now, huh? So, you know, and you can really see the story. So this is the 70s. This is when this Congress started, that big depression of the 80s. And this is where we're back at now. We don't have 2009 in this, but we're back at 10% in the US. So this is a huge amount of history. But so again, this has been extracted from that data set. But that's great, but how do we scale? I mean, this is all great for me, but I want to take that data, interact with all kinds of other things, and I can't do it all, right? I have a limited amount of time. It's only me or my corporation or whatever it is. So how do we scale? I mean, what we really want to build here is large-scale data infrastructures. We want to build stuff like operating systems, but for data. We want to build big, relatively, bigger than any individual or any corporation. So how do we do that? How do we build complex things? One answer is we use lots of labor. These were basically the tallest, at least, man-made object till the 19th century, for about 3,000 years. We think they employed about hundreds of thousands of people at a given time, though not particularly oppressively, in fact, it turns out. So that's one option, is we can just use lots of people under some central direction to build these things. But it's actually quite a simple thing, a pyramid. I mean, it's big, but it's pretty simple. But what about the Empire State Building? When we build bigger stuff, it gets more complicated. Is the architect telling that guy exactly what to do? Probably not. It gets too much for one mind. So how do we deal with this? We divide and conquer stuff up, right? We break down complicated problems into small parts that I can deal with. I can deal with getting US unemployment data, and you can deal with getting inflation data, or, you know, GDP deflators, or the price of wheat. We want to break data down into chunks that can be individually managed, packages of stuff. Now, this is really, in a way, revolutionary. Most systems, when they're small, get built in one way. When you have an early computer, one team builds everything. You know, often you just rebuild the OS for your particular system. You rebuild the set of libraries. And the problem is, when you break stuff up, how do you put Humpty Dumpty back together? Right? If you just break stuff up, if you just atomize it, you're a bit screwed, because maybe you just have a broken egg. You've broken everything up, which is great, but you've got no way to put stuff back together again. What do we mean when we do about packaging? What is all the effort? When we talk about Debian, do Debian actually write any code? But relative, yeah, you're right, they do. But relative to the packages they use, what's the contribution of Debian in terms of pure source lines of code relative to the stuff they use? Anyone have an estimate? 1%. Maybe even less, I would guess, compared to the Linux. Huh? Much less. So you've got this whole project that doesn't actually create any, in theory, new material. What do they do then? What is all that effort about? Plugging stuff back together, right? I mean, making sure all this stuff generated by different people actually works together in some way. Like a lot of effort gluing things together. So it's about the packaging and putting things back together. So there are two different models about how you can do this, and I think this is really important. So one is, we have kind of a one ring to rule them all. Yeah, you have one centralized system, and you know, we don't want to speak names, but let's say Microsoft or Google. All the data will end up in their system, or all of the code ends up in their system, and they make sure it works, and they give you the APIs, and they give you the formats. And it's probably closed, and most data is currently like this. I mean, let's just go through. Think of finance data. Almost all finance data is closed. Like Bloomberg, Thomson Reuters, anyone with big data sets about finance, it's closed. You have to pay, it's proprietary and closed. You even think of science. You think about prices. I mean, hey, would anyone like a price history of all the stuff we buy? Can anyone name a data set where that's openly available? What about sales? Really crucial. I mean, I'm talking about economic stuff because that's where I come from, but most major data sets you can think of are currently closed and proprietary. And it's a kind of one ring to rule them all model. Everything will come in. No, the revolution should and will be decentralized. So what does that mean? What it means is we don't have one person in charge in some sense. Remember, that's the many mind principle. The best thing to do with your data will be thought of by somebody else, not by you. So we want a model where small pieces are loosely joined. We want to break stuff up. We want to let individual people make stuff and not have to comply necessarily with the central authority. So that means sharing and separation. I can do stuff without having to worry what you're doing. We don't need some central architect telling me and you how we should coordinate and how we should do stuff. But it requires openness. This is really crucial, right? For this model to work, it's really hard to do if you have to go and seek licenses from everyone. If every time you want a piece of geodata or postcode data or whatever, I don't know here in Germany, you have postcodes, right? You have these 5-digit codes. Is that openly available? Anyone can get it and reuse it. You don't have to sign any license agreement. It's hard to find, but you found it. And what form is it in? Text, a text document. And how does it give you long laps? I mean, what use is the postcode unless it resolves to something else, right? What do these list of postcodes give you in Germany? Right, and if you get the data out of Google Maps, who've paid money to some gazetteer to give you long lats out, is that free or not? Would you be worried that one day the people Google have paid money off? Because remember, Google don't care because they're just licensing. But the people who've given it to Google been paid some money will come after you. It's really unclear. It's why it's really important to be clear. But we require openness to do almost all of this stuff if we want to do it as a community and we want to do it properly. We need openness. It's really essential. And almost no one's put a license on their data currently. No one even thinks about it. So it's essential. So how do we make it happen for data? How can we do this? So go back, because everyone here, how many people here haven't used some flavor of Linux? Normally, the other place I talk, I get very different responses to that question, unsurprisingly. So there's something really miraculous about this. We should almost, I mean, it's difficult in this hall, but get down on our knees and worship. Because there's something truly, truly extraordinary about this. Because most of the people who've at least packaged up this stuff have never even met. And this is probably, in fact, I would put a big bet on it, the thing running on your laptop is probably the most complex artifact we have ever created, that humanity has ever created, in terms of the number of man-years, the complexity of conception that it encapsulates. This is the most complex artifact we have ever made. And yet, at least in running these distributions, many of the people who are putting it together have never even met, may never have spoken to each other. And imagine they did, how horrendous it would be. I mean, it's the kind of thing that does cripple. You feel very large corps when they try and do this thing eventually, which is that they subscribe to a more centralized model. So amazingly, we can build something really complicated in a very decentralized way. In a way that means when I can say, oh, I want X done, and like 35 packages that all have some dependency between them are installed magically on my system, and at least most of the time work, right? So this is truly miraculous, and it's something that we take for granted too often. So what would we like? What goes into making apt work? What goes into making it tick? There are two things. There are two things that go into it. First are APIs. right? First is that when you install like libc and you install Firefox, and like Firefox needs to talk to libc, they are the right version, they've published a bunch of documentation that means there's a bunch of calls you can make.